Somewhere beyond the stars, something is coming. It's not a myth. It's not a story. It's not a theory whispered in underground forums. It's real, and it's getting closer. The object, coldly catalogued as 3I Atlas, was supposed to be just another interstellar visitor, an icy rock drifting silently through our solar system like Oumuamua or Borisov before it. But now scientists are no longer so sure. What started as a quiet observation turned into a growing nightmare as the data began to suggest that Atlas is no ordinary comet. Its tail isn't behaving like dust. Its movement doesn't look random. Its composition doesn't match anything found in natural celestial bodies. And its trajectory, that's the most disturbing detail of all. Because Atlas is headed toward Mars, but not in a way that feels accidental. It's threading the solar system with a precision that almost looks deliberate. And if what it's hiding is what some fear, then we may be witnessing the first maneuver of a machine not built by human hands. This is not just an astronomical anomaly. This could be a warning. And what comes next might shake the very foundations of science. At first glance, Atlas fit the mold of every icy vagabond we've spotted near the solar system. Astronomers peered through Gemini South in Chile, expecting to confirm a dusty tail. Maybe some jets of vapor. What they saw instead was a tail that defied the laws of nature. It didn't disperse. It didn't sway under the push of the solar wind like a tattered flag. Instead, it extended with symmetry, with force, with shape. It sharpened into a blade, broad, clean, and unnaturally defined. Every stage of its growth appeared intentional, almost modular, as if it were being assembled piece by piece. Unlike natural tails, which drift based on solar interactions, this one showed signs of control. That single observation cracked the shell of assumption wide open. Astronomers, now facing what looked less like a chaotic outburst of gas and more like the exhaust of propulsion, began whispering the unthinkable. What if this wasn't just sublimation? What if the tail wasn't a symptom but a signal? Then came the data from the James Webb Space Telescope, and what it found deepened the mystery. Surrounding Atlas was an enormous plume of carbon dioxide, 350,000 kilometers long. That's nearly the entire distance between Earth and the Moon. But here's the strange part. Even that massive plume didn't behave the way it should. Scientists expected solar wind to stop the plume's expansion much earlier, to push back and contain it. Yet the gas kept spreading, uncontained, uncontrolled, yet still too short to account for any kind of dramatic thrust. The numbers didn't add up. Something was off. And even more disturbing, despite such intense activity, Atlas's trajectory remained laser straight. Natural comets wobble and shift as their gases escape, their movements altered by each puff of vapor. But Atlas, it flew like a guided missile. No deviation, no hesitation. The CO2 was screaming chaos, but the path showed order. That contradiction tore a hole in the natural explanation. It was behaving like it had navigation. And just when astronomers thought they had seen the strangest part, they zoomed into the nucleus and found the most shocking discovery yet. Its brightness wasn't caused by ice or exotic gases. It was metal, specifically nickel, not in tiny traces, not in accidental coatings, but in concentrations high enough to reflect light like industrial alloys, the kind humans use in spacecraft, plating, and machinery. Suddenly, the brightness made sense. But the origin didn't. Natural comets don't form with this kind of refined metallic coating, not even close. And the presence of nickel explained another anomaly: stability. Outgassing should fracture or wobble the comet's core under pressure. But Atlas stayed locked, still precise, like something reinforced. Not fragile, not random, but designed. Astronomers dubbed it the nickel mystery. But many began dropping the word comet entirely, because a metallic shell that reflects sunlight perfectly and resists fragmentation doesn't sound like a frozen rock. It sounds like armor. But even the metallic mystery isn't what made scientists lose sleep. It's the trajectory. On October 3, 2025, 3I Atlas will brush past Mars at a distance of just 29 million kilometers. That might sound far, but in celestial terms, it's terrifyingly close. The minimum orbital intersection distance is even more precise: 2.7 million kilometers from Mars's orbital path. That's not something a random comet just happens to do. Interstellar objects wander through the galaxy for millions of years. Their paths are erratic, pulled by gravity, warped by stars. But Atlas is threading through our solar system like it knows where it's going. It's not wandering. It's aiming. Like a dart thrown from another star system, it's slicing space with almost surgical precision. And when scientists ran the numbers, they found something else. A tiny adjustment, just 10 to 15 km/s, could alter Atlas's path enough to send it directly into Mars. And that is not a comet behavior. That's maneuvering, with a plume that large, a tail that's structured, and a trajectory so deliberate. Scientists expected chaos around Atlas, shattered fragments, volatile particles, secondary trails of debris, but the space around the object remained eerily clean. No secondary jets, no splintered offshoots, no irregular shedding. That in itself was strange. Most comets suffer structural instability when subjected to that kind of solar pressure. They bleed fragments. They shed mass unpredictably. They flare, but Atlas held steady. And what it didn't produce was as important as what it did. This lack of debris made researchers suspect something far more engineered. If Atlas is undergoing intense activity, releasing gas and heat, and yet still maintains a clean path without loss of core material, then we must consider what kind of structure could survive that intact. Could it be hollow? Could it be a shell? Could it be a vessel? Every theory pointed away from nature. And still, amid all this strangeness, Atlas has remained completely silent. No obvious radio emissions, no heat anomalies, no artificial signals. But maybe silence is the message. The team at Gemini, South wasn't the only one monitoring Atlas. Instruments across the globe and in orbit began, picking up light signatures from its surface that defied standard reflection models. Most comets have predictable albedo, how much sunlight they reflect. But Atlas was different. It fluctuated in strange patterns like light, pulsing across a curved, semi-reflective surface. Some researchers speculated that the material was refracting light like a smooth metal, not scattering it like dust. That explained why the tail glowed so uniformly. But there was something more. When analyzing the light curves across several wavelengths, an unusual peak emerged. Not one matching natural elements, but something closer to engineered materials, perhaps layered composites or heat-dispersing alloys. These were materials we've only begun to test in labs on Earth. But somehow this object, if it is one, was covered in them. If true, that would imply the presence of either an extremely rare natural process we've never encountered or technology far ahead of us. And either possibility rewrites the story of interstellar exploration. Atlas didn't just appear randomly. Its timing is becoming just as suspicious as its behavior. It arrived shortly after the James Webb Space Telescope began its full observational operations, at a time when Earth's ability to detect and analyze anomalies had reached an all-time high. If it had passed by just a decade ago, we might have never noticed the subtle clues, the light shifts, the CO2 plume, or the metallic composition. But instead, Atlas enters our solar system now, just when we're best equipped to see it. Coincidence? Maybe. But when you stack that with its trajectory, the composition, the tail, and the lack of debris, the theory that Atlas is not just passing by, but delivering something or collecting something starts to gain traction. Some scientists now consider a more radical idea. Atlas is part of a pattern, a cycle of visits, perhaps even a network of scouts operating across the galaxy, with timing aligned not by randomness, but by observation windows. There's one final theory gaining momentum, a darker one. That Atlas is not a probe, not a beacon, not a scout, but a test, a way for some distant intelligence to measure how a civilization responds when confronted with the unknown. Our telescope spotted it. Our media ignored it. Our scientists argued over it. And our governments remained silent. Could this be what Atlas was designed to provoke? Reactions, data, psychological and technological metrics. It wouldn't need to do anything obvious. No flashing lights, no language, no transmissions. Just be anomalous enough to spark the right minds into curiosity or panic. And now that we've studied it, published papers, launched predictions and modeled collisions, what if it has already gathered what it came for? What if the mission wasn't to contact but to analyze? The trajectory, the tail, the composition, it could all be camouflaged for the real experiment. And if that's true, the scariest part isn't what Atlas is. It's what might follow it. One of the most unnerving aspects of Atlas is how little it seems to be changing. Comets are messy. They evolve. As they get closer to the Sun, they shed material. They spin irregularly. They sometimes even fragment. Their shape, brightness, and orbital path are in constant negotiation with solar radiation and gravitational tugs. But 3I Atlas doesn't play by those rules. Despite crossing regions of increasing solar intensity, despite trailing a massive plume of gas, it holds steady, no fragmentation, no measurable spin, no signs of structural decay.